In this problem, we want to find the limit as x approaches negative infinity. So as x approaches infinity or negative infinity, we use a little bit different approach here. If we were to think about what happens when the value of x decreases without bound, in other words, it goes towards negative infinity, the numerator and the denominator here would approach negative infinity. But that is another indeterminate form. Just like 0 divided by 0, infinity divided by infinity, negative infinity divided by infinity, negative infinity divided by negative infinity, any of those are indeterminate forms. So what we need to do here is multiply by a well-chosen 1, and that well-chosen 1 is going to be 1 over x cubed over 1 over x cubed. So that is a 3 there. So this gives us the limit as x approaches negative infinity, and 3x cubed times 1 over x cubed is just 3. X squared times 1 over x cubed would be 1 over x. 1 times 1 over x cubed is 1 over x cubed. So that's our new numerator. And then the denominator, x cubed times 1 over x cubed, is 1. And 1 times 1 over x cubed is 1 over x cubed. Now it's easier to think about what happens when x approaches negative infinity. Positive infinity on this particular problem would work the same way. So we have 1 divided by negative infinity. Well, any finite number divided by either positive infinity or negative infinity is going to approach 0. So as long as you have a finite number on the top and the bottom is approaching infinity or negative infinity, that part of the expression will approach 0. So this will also approach 0, as will the 1 over x cubed in the denominator. So we end up with 3 over 1, which is 3. You could also consider this problem from the standpoint of graphing a function. So if f of x is equal to this expression that we have here in the argument for the limit, then we remember from college algebra that if the degree of the numerator is the same in the numerator and if the degree of the numerator is the same as the degree of the denominator, then there's a horizontal asymptote at y equals 3 in this case, because we have 3 divided by 1. There would be a coefficient of 1 in that denominator right there. So we would have just the horizontal asymptote at both ends, at both sides, far right and far left. We're interested in the left here since we're approaching negative infinity. So hope that helps.